Today we are going to talk about how to build self-service inside data engineering. And the topic, the content, is going to be about some generic info about data at Picsart, data architecture, zoom out, where we are working, what is the infrastructure about. Then some few words about data teams, how we are cooperating and so on. The aim and values of building self-service inside company at all, not data engineering. Toolkit and self-service architecture that, more in zoom-in mode that we are going to talk about, and then challenging of having self-service inside companies, supporting it, and so on. First, whoever knows Picsart, this is editing application, photo, video. Initially, it was on mobile, very active, but now we are aggressively moving to web market. 150 million is our monthly active users on mobile devices on both platforms, Android and iOS. Daily flow of new installs is 1.5 million users from worldwide. And I mentioned public content here, 300K, which is the one that Picsart users are editing, remixing each other, photos, stickers, and so on. But the content being generated is nearly about 1.5 million. The data. Mainly the data is about users. So we are generating users' data on their mobile device. We are supporting its, let's say, integration with our services. And then it comes to Picsart data infrastructure, nearly to 7 billion rows daily with 150 messages per second. This is the user data, let's say. And of course, there are several other ingestion pipelines that we are doing for our business users and so on, nearly 100. And yeah, the size in Parquet format, compressed 1.5 terabyte daily, which is quite big thing to understand how to deal with that. So the next, we are going to talk about our architecture zoom out.
So let's have a brief overview of the data engineering architecture inside Picsart. Three main components that we have here are on-prem services here, AWS services, and SaaS products. And SaaS products like Looker and Platform. Two main data ingestion pipelines that we have are one from third-party sources like Apple Store, PayPal, and so on. And the main data we process with Kafka with structured streaming. Let's start from on-prem services. Here we have some black box, which is about we have custom SDK, which is integrated with our mobile applications, and it's responsible for collecting the events starting from user journey and sending those events to our receivers, which produce those events to our Kafka as the messages. Here is the Kafka on site, and what we have here. April is our orchestration tool. As we have different jobs that we need to run with different dependencies and different times, we use April. DBT is our orchestration. DBT is our transforming tool for transforming our data. In addition to our main mobile events, we also keep two engineering data. Business is not interested in that data, but we store our crashes of the applications in Elasticsearch. And also embedded data is stored here. Why we store these crashes? Because developers can group those crashes and see what's causing them and to fix them later. And in Prometheus, we store our monitoring data. Streaming jobs have their metrics about their RAS. And by monitoring these metrics, we can see what jobs we can optimize. We've integrated all of our services to cloud, and only Kafka is left here. So to have the data in AWS Kafka, we use Kafka mirroring here. In other words, these upper and below Kafka contain the same, but they may have different configurations. On-prem Kafka is our safety zone. It's considered to be our safety zone because the retention is higher there. And in case of any AWS issue, we can turn off the mirroring and have the data from there. Then we have two AWS services, EMR and RDS. In HBase tables, we have some aggregated results of our statistics jobs for backend. And in Postgres, about our self-service. I'll talk about this topic later. Our main tool that we have as a data platform, we use Databricks, not only for data engineering team, but for all the data teams. Databricks is running with our AWS account on top of EC2 instances. And let's go to our medallion architecture. For DBT, we use medallion architecture, as you can see here. Rather than keeping all the data perfect at once, we improve the quality incrementally. First, we keep the raw data in bronze layer. Then we do some aggregations on top of it. We do the cleaning, we do the duplication, and keep the data in silver layer. Then on top of the silver layer, we have aggregated and ready for BI data or business-oriented data in gold layer. And on top of this gold layer, we create our dashboards, and for BI tool, we use Looker. Also, besides Looker, we have Upland, which is our data catalog. We store the information about our tables, about their owners, about who created that model, and so on in Upland. It is not only for data engineering, but for any other teams like product managers, data scientists, and everyone else can look at the data and see the description about the columns of that data and so on.
In that architecture, there are three teams that we are working together. This is data engineering, data science, and then machine learning AI teams. So with very simple visualization, what we want to show here is that data science is, let's say, more or less distributed across business units. AI and machine learning are helping any business problem, any business issue inside Picsart, implementing them inside business unit, and then, let's say, going through the next problem. And data engineering, which is the, let's say, main data ingestion, main data provider team here, is, as Anna told, building the data, I don't know, ingesting, enhancing the data, and so on. And the handover line is right after that. I mean, right now, we are bringing whatever our business, our teams are needing, but then, I mean, it's being handed over. And the idea, like we are saying self-service, but this is, the self is ourselves. So what we want to do is to be able to help our data processing teams to be more, let's say, to have more business-oriented data, business-oriented data units, and move the handover line towards business units, because otherwise, I mean, there are some problems that we want to solve. The problems actually that we are trying to solve are, they are all about engineering or business. So centralized data infrastructure and automated transformation pipelines. Let's say the crucial thing here, because if the data transformation pipelines are not centralized, then business, let's say, decisions also are based on not centralized information, and they may differ with some very crucial KPI metrics. So we want to keep them in track. Foster a strong culture of data sharing, knowledge, best practices. This is more about helping anyone inside Picsart that are using data, or at least they want to use, to understand the data, to understand the, let's say, glossary at all, what we have, why we are keeping this or that, and what are the details, and also some, I don't know, performance optimization and so on, that having centralized pipeline, you can work on that center and gain a value. The next one, align and simplify data governance inside Picsart. I already touched that topic. So what we want to achieve is that saying that we are data-driven company to be rule and, let's say, fact inside companies. So anyone who is using the data knows or can know anything about it. And make data delivery to all data teams more reliable and reusable. This is the thing that we are talking about. I mean, all the teams that are using the data, having better quality pipelines, having better, let's say, ingestion pipelines and so on, are going to affect all data teams. So this is the aim, at least. And the values. Set up once, enjoy endless. This is, let's say, very romantic, but this is the thing that we want to achieve. I mean, not to go back every time to the same pipeline and say that, guys, sorry, but can we increase precision from 4 to 6 and do that in 100 places? Just set up it in one place and then gain value from it. Reduce cost, execution time, and open new possibilities. Working with 3 data teams, let's say with nearly 100 people, the cost reduction is becoming impossible because you are making everything out of control. So you need somehow to be able to centralize the problem into one place and then, let's say, kill the bad guy in that place. Have single source of data for different reporting pipelines. This is very, let's say, clear. So what we want to do is, if someone is talking about any metric, any KPI, anything about his business unit or Picsart at all, then we want them to know what exactly the source is and be sure that it is secure to use, and they can use the data without any questions to data engineering team. And then made data quality to work for us, not backwards. Maybe the second romantic point, but data quality is something that anyone who is using data is suffering anytime. So what we want to do is to set up the data quality strong system and then make sure that quality is providing us more insights than we spending our time to fix this or that bug in the pipeline. Having all that, let's move to more closer view of self-service architecture and toolkit.
Let's start discussions about DBT. So what is DBT? First, DBT, Dialectical Behavior Therapy. Developed at the University of Washington, it was founded to reduce the depression, stress, and anxiety. Okay, I'm joking. DBT is data build tool. We're using it as a transformation tool to write some SQL queries. And what are the key concepts that are the reason that we're using DBT? First of all, it's really easy to write SQL queries. And second, we can use also Jinja macros, which are, and with using them, we cannot repeat the code as most of the SQL developers do. And third point that it's useful is that it's keeping the dark of our jobs because they are dependent on each other, and it's really hard to run all of these jobs without having these dependencies. Also, we do some testings here because we have some common schemes and do the validations on top of that to see, for example, if the specific column contains nulls or the specific column contains duplicate values, and removing them. And the 5 point for using DBT is because it's really easy to change the documentation and have descriptions for these columns. All the DBT codes are stored in GitLab, which is our version control tool, mainly because of its pipelines. One of those pipelines is wraps the DBT code inside the Docker image, and Airflow is the tool which is responsible for running these jobs. It uses Kubernetes to allocate the resources and manage those resources. It creates Docker containers on top of Docker images created by GitLab, and for running these jobs, it triggers Databricks clusters. And all the results of these jobs are stored in AWS S3. So we have 2 environments here. One is production and one is development. So the developers cannot harm production tables and store the development and store the data in development stage. So they can do some tests on top of it without harming the actual data. We store we do shallow copies of the production tables and store them in RDS. So it's that's why we put metastore RDS here. And let's talk about how we store all of these models. We use dimensional modeling here, and to visualize them, we use Looker with 2-layer visualization. And that means that we keep fact tables and truth tables. Fact tables are aggregated results with some common dimensions, which means we aggregate our events and join with some common dimensions. For example, we have a dimension which shows everything connected to location of the event, and this dimension is joined in all the other tables. So it's really easy to, in visualization part, to give as many as you want to see what filters you need. and to change them. And the cube one is created with pre-calculated values because it's not too fast to show the fact tables. That's why we have also cube dashboards for fast visualization. As I already mentioned, Atlan is our data governance tool. We store information about our tables, about the owners, about the business unit, and everything else. So it's really easy, not for only data engineers, but for the other teams to go through it and see what they are interested in.
We are trying to solve incrementally is business engineering connection. There are some jokes like we need data about our users. Okay, it's 10,000 rows or 10,000 gigabytes. Okay, thank you. But this is not the way business is going to gain from the data, and this is not the way engineering should provide the data. So by having these, I mean, the interaction between business and engineering is going to increase, of course, and each business decision should have data, at least some background, which requires engineering on top of that. And each engineering decision, like ingesting new data, bringing some new transformations, doing some hard, I don't know, stuff with data to have the result table for business, requires really big business understanding. Otherwise, I mean, they are not interconnected. The next one, Platinum layer uncertainties. What does that mean? As Anna mentioned, having these fact dimension tables on, let's say, minimum grain, which means that it may be device, it may be user, it may be session even. It's really hard to manage the size of 7 gigabyte daily data, terabyte, sorry, daily data, and I don't know, analyze 1 month of your business questions. So that's why there are some implementations already, and we are constantly trying to move forward with that to have faster reporting, but not drop the possibility to deep dive into models that we are building, because with help of that dimensions, there is endless opportunity to deep dive and understand, I mean, your user behavior with new filter, with new distribution, and so on. One-to-many quality issues, I touched this in previous slides. So seems having centralized pipelines and that kind of beautiful stuff is very nice, but if you are failing now, you are failing in, I don't know, 50 possible downstream jobs, which means that your quality control or any let's say test implementation should be final and should have also all the alerting stuff and so on. So when you are breaking something, you are breaking all upcoming ones also. And the one, centralized efforts, this is more about teamwork, but not inside data engineering, but inside engineering, science, machine learning, AI, and business teams. Why? Because usually when you are dealing with 40 people DS, 40 people AI, 25 people data engineers, then you need to go back to this business understanding, because otherwise no one needs your data, and try to somehow build a pipeline together, which is let's say managerial processual thing that needed to be solved. I believe that's all. Thank you for listening. Any questions?
I have one. Isn't it easy to do the failure tolerance via availability zones on AWS instead of having your own backup of Kafka?
Yeah, on premise. It's easy. It's easy to do some disaster recovery. Even Databricks that we are using provides that. But on premise, let's say cluster services that we are keeping Kafka on it, it's not just for, I don't know, recovery and that's all. There are several systems that are still being sourced from on-premise Kafka, and I mean, we are keeping them not just to have Kafka higher retention for main topic, and not to lose data in case of any incident on AWS side. But of course, there are several, let's say, pipelines already implemented, but more, I mean, higher level of view this incident management from Databricks, which could be implemented. Great.
So is it like one of the data warehouse so data people use which layer?
It starts from Silver because you can just limit your data people with aggregated data and say, guys, this is your business data. But I mean, Silver and Gold both. And by the way, sorry to add, Gold is not assumed only aggregated. It may be, let's say, business prepared data like user level log or something, which is also Gold because it's directly going to some analysis or KPI reporting. If you could specify what test data is, then I can answer. Okay, got it. Yeah, in dbt we already have test cases implemented, which is like more physical quality layer. Yeah, I mean, data rows are consistent. I don't know, some very high level checks. And of course, there are some that we can't control in dbt or something because for quality reporting, we are building separate table from metadata and let's say data and building visualization and setting alert on that. I mean, it's kind of not directly only test cases quality control because it controls only physical, let's say, part of the quality. Is that answers to your question or not?
And also, you said that not only there, there. So is there something that activity something like that? You should consider as a silver layer or gold layer.
Activity stream.
Like all the event logs and for example, I just have not defined the same schema because each event is kind of different. Like properties, but do you have something like that? Which layer you consider?
Actually, it's hard, but events are having same schema. On our case, we try to do that at our best. But of course, the bronze layer is dedicated for that. If there is a stream that I don't know is coming from two or three different sources or so on, then it's all in bronze. And then we can think about how to process it, how to make it clear, usable, and so on, and how to separate it maybe to two or three different appropriate tables in silver layer. But the backup zone is still bronze in any case.
There are 10 different events, because of 5 fixed parameters, like user ID, something like that. And each event can have like additional, some can have additional 10 parameters,
Mm-hmm.
3 parameters, and you can like put everything in the same schema. So what you do in that case, which table you play and which layer you consider that.
Mm-hmm. Got it. In our silver layer, we keep our data, which like 25 very common columns, and then we keep some map string or something kind of column where we are putting all these, let's say, very specific event specific columns fields. We are not keeping, let's say, very specific tables separately, but of course, if there is a business question that need to analyze something from this map string, but the JSON should be processed or even it's hard to, as a compute, hard to manage and so on, we are preparing that in silver layer directly. But I mean, we are not fully dynamic in the schema management, let's say, but of course there is a part that we don't want to overhead ourselves because I mean, there is no value from that. Any other questions, guys?
Quick question about the Atlan. You said that you use that for metadata and schema, I guess. How do you guys keep that up to date, and how do you ensure that every time you write data, it does conform to this savings?
No?
So often the data governance tool, and we have different pipelines in GitLab. For example, one of them is using dbt codes, and also in Looker change. Every change that we do in Looker side and dbt side is updating the metadata. And often I had some different integrations, which some of them were already in Atlan, but some of them doesn't cover our needs. So our team did those integrations. For example, Looker integration is done by our team.
So before you write the data, you can sort it out and then write the data out to the data lake?
You add the document, the descriptions in dbt, and it edits those. And the pipeline, each time the pipeline works after you open the merge request, it also updates the data in Atlan.
There are actually some out-of-scope integrations, but for some of them, we are using our own, let's say, crawlers or something. and it's different. I mean,
I was just thinking Databricks.
yeah, in S3 we also keep some metadata that is not out of box implemented and so on. And then with Atlan, let's say crawlers, we are bringing that to Atlan. The update, for example, in S3, as soon as you have something new, it will be moved to, let's say, crawler will work and move the new information metadata to Atlan. If it is, for example, DBT, then as Anna said, like GitLab provides that update. If it is Looker, again, I mean, with some, let's say, frequency, we are updating Atlan metadata that is coming from Looker because it's not very high speed changing. Yep.
I'm Anton from Manichat. I would like to ask, so analysts and data engineers and other guys are acquiring data from with Looker, am I right? Get some insights or.
Okay.
What's the instrument that, for example, product guys work with data?
Okay, got it. So product guys actually work with data, let's say, from Looker, because that's where, I mean, it's easy to understand, it's easy to see and so on, and it's colorful. If they have some understanding about, I don't know, SQLing things and so on, then Looker has its own, let's say, place that you can do that, or Atlan even has that same thing. Mainly, all other data guys like scientists, BI, ML, and so on, they are using, let's say, data from S3, not from Looker, not from anything else. Yes, SQL, Scala, Python, PySpark, it depends. But actually, I mean, it's better to have everything on Looker, but you can't keep that because they need their own transformations after our transformations and pipelines and so on. As we talked about handover line, I mean, we want to move the handover line as near to business as possible. But of course, data engineers can't build some ready data for machine learning model or can't build something that is, I mean, responsible for deep dive the incident or something. Yep. So Databricks is the place that they are interacting with data. Thank you, everyone.
Thank you
for your participation.